Sathyabama Institute of Science and Technology.
Good day all. Welcome to Sathyabama Institute of Science and Technology YouTube channel. Myself Aishwarya from the Department of Computer Science, Sathyabama Institute of Science and Technology. This video is all about a tree in data structure. Let's see what is tree in data structure. So before starting this particular topic, I want to tell you what is the key success of your career. So I want to tell keep educating yourself. If you educate in daily basis, definitely that is the only key for getting a successful career. So the topics to be covered is understanding the need of data structure, a basic introduction of the data structure concept, an introduction to tree, terminologies of tree, representation of tree, and finally I end up with a real-time application and what are the application of tree will be existing. So understanding a need of data structure. I want to tell you about the data structure in real-time concept. Let's take our restaurant. While looking into the picture, you can clearly see that is the properly arranged restaurant will be there. Let's think about, imagine about the restaurant which is having 40 chairs and then there is 2 servants and there is 2 cook and 3 sweepers will be there. Let's think about the chairs are not properly arranged and the sweepers are not properly cleaning the table and the cooks are not getting the food ready on time. So what happened when the customer is complaining about that? So what is happening? The data is not organized. In this particular restaurant manner, we can say the chairs are not properly arranged so that the customers are waiting. So even though 40 chairs are available, some of the 20 people are waiting outside because it is not properly arranged, not cleaned well. So from this concept, we should understood in the real-time scenario, we can understood that in the daily basis, there is n number of data will be there. If you taking the Sathyabama, there is a n number of results will be there and n number of students will be there. So if you properly arrange, then we can easily get the result by keeping the register number on the particular web application so that we can get the results. If the data is not properly arranged, so no student can get the data and no students can get the result of the particular examination. So this is the common real life example for the data structure, for understanding the data structure. So from this what you understood, data structure means we are going to organize the data in the proper way so that we can easily retrieve, we can manipulate and we can select and we can design. This is what the understanding of the data structure. And the next one, what is the basic introduction of the data structure? So today concept is all about a tree. I'm going to tell you some basic introduction about the data structure. So as we all said, data structure real life example as a restaurant, and now the data structure can be divided into 2 types. One is primitive, another one is non-primitive. A primitive is nothing but we can store only a single data type. What is data type? Data type is nothing but here I have given some data types: integer, character, float and double. So integer you may know that is number, and the character you may know that is the word. So you can able to store any one kind of data types. If you jump into the non-primitive, you can save multiple data types, so that comparing with the primitive, non-primitive will be the advanced one in the data structure. So in that again in the non-primitive we have 2 different types, that is linear and non-linear. So under linear, the name itself mentioning that we are going to arrange that particular data in the contiguous manner. So here under the linear we have array, stack, queue and the linked list, and under the non-linear we have tree and graph. So today concept is all about a tree in data structure. I'm going to tell you what is tree, and here it is. So basic tree concept. So before getting to the technical terms or before getting to the proper definition, I want to tell you to look this particular graph. So what is happening here? So it is a college map. So there is a director, there is a under director, there is a dean, under dean there is a HOD, and under HOD there is a faculty. If you want under faculty we have a students, like that we can build the tree. So what is tree? So tree, as I already said, tree is a non-linear data structure. So here we are going to arrange the data in the hierarchy manner, means a step-by-step manner. So here you can look into this particular director. This is nothing but the node. So each node having some information, some data. It may be integer or it may be a number, whatever. So this is what the particular thing. So here I want to tell you it is a non-linear. It comes under the non-linear data structure and it is a multi-level hierarchy. As I said, it is a multi-level. So it is not organized in the linear manner. It is in the hierarchy manner. So here a multi-level is another name is nothing but the hierarchy. So the basic tree concept definition is collection of entities or nodes linked together to stimulate a hierarchy relation. So here this is nothing but the node. Everything will be connected with each other, but very important thing here, it is unidirectional. So this is the unidirection. For example, if I am taking employee name, so that particular employee name have an address, or that particular employee name have some salary definition, and then some employee ID will be there here. So this every node have some information. So here next one, top bottom approach. So as I said, it is a tree. So tree is having, whenever we are thinking about the tree, we can tell tree is having root, branch, leaves. The same thing here. So but here the root will be in the topmost node. So here this is a top bottom approach. So what happen, if it is tree, there is a bunch of leaves will be there, branches will be there, and roots will be there. But in this tree concept, in the data structure, that is upside down. So first root will be there, then these are all the nodes. So let's see the example. So you look into the tree. So I just make it upside. So meaning this is root, and these are the branches and leaves, the same like here. So this is nothing but the root and followed by the nodes. So everything having the information, even the node and even the root and node, everything having the information. And next one. So here I am going to tell me about the terminologies of the tree. What are the terminologies existing in the particular tree? As I said, here A is nothing but the root node. How can I find out by the given tree what is the root node? So which node is not having the parent node? What do you mean by parent node? Just look into it. So no parent, a topmost element or the first element in the hierarchy. If I am taking B, who is the parent of B? A. For C, who is the parent of C? That is A. So from this we have to understood. So in the example they are asking, they are giving one tree and they are asking what is the root node. The first point you should know what is the first topmost element, and then you have to check that topmost element having any parent node or not. But this A is not containing any parent node, so we can understood in this particular example A is a root node. That is what the first important terminology is in the tree. The second one is node. As I said, everything here, everything is a node. So everything having some information. That is what the node. The first one is root, the second one is node. So example I have given here. The next one, a parent node. So very, very important. Here, parent node is nothing but the immediate predecessor of any node. For example, if I am asking what is the parent of D? The parent of D is nothing but a B. Predecessor means a previous node, immediate previous. So you can say this is a previous node, this is the previous node for the particular D. But I am telling immediate predecessor. So for D, immediate predecessor is a B. So the parent of D is nothing but the B. Let's see the example. A parent of E. Just look into the parent of E. So what is the immediate predecessor? Is B. Let's see another example. Parent of a K. So K is here. What is the immediate predecessor? That is C. That is what I have explaining here. That is what the parent node. Let's see the next terminology. Child node. So here immediate successor of node. What do you mean by successor? An immediate next node. So your predecessor is a previous, successor is a next. Let's see the example. What is the child node of A? Both B and C. What is the child node of F? L and M. So these are all immediate successor of node, means a next node. Previously in the parent node we understood that immediate a predecessor node, here immediate successor node. Let's see the example. Who is the child of A? As I already said, immediate successor B and C. And what is the child of K? So let's look into the K. Whether it is having any immediate successor, is there any other node will be there? No, right? So we can see there is no child for a particular node K. So I am just mentioning here a null. So next terminology. Here the next terminology is all about the brancher. How tree is having the branch? The same thing in this tree in data structure also having the branch. So relationship between a parent and child also called as edges. You can take anything. This parent and child, any combination. E and K, F and M, G and N and G and O. So if you look into it, everything that parent and child have one link, that is nothing but the branch. We can also say that is the edges. So here branch is nothing but the link between the parent and the child. The next one, external node. So external node is nothing but which node doesn't have any particular children. There is no children. That is nothing but the external node. For the given tree, we have A, B, C, D, E, F, G. All are having children. But look into the last line, faculty line. So what is happening there? H, I, J, K, L, M and O. This all are having the parents, but they are not having the children. So we can easily identify from the given tree what is the external node? H, I, J, K, L, M and O. So it is easily understandable. That is what the example I have given here. So the next one, internal node. So internal node is nothing but a non-leaf node, means which contain the children. So in previously I have told you the which is not containing the children, now which containing the children. So from this example tree, we can identify what are the internal node, A, B, C, D, E, F, G, because all are having their children. They are considered to be a non-leaf node. So the another name for external node is a leaf node, because that is not having any children. The next terminology, a path. As I already told, branch. Branch is all about the connectivity between the parent and the child. The path is nothing but, suppose, just I am asking you the question. From the root node, please reach J. So what you will do? From A, you can travel B, you can travel E, and you can reach J. This is nothing but the path. From the root to the mentioned node, if you are traveling, that is nothing but the path. So you should know the difference between a branch and a path. That is what the example here I have given. The next one, ancestor. So this is very important one. So any predecessor node on the path from root to that node. So let's see the example. I am asking you, what is the ancestor of E? What is the ancestor of E? So here I have given A and B. What is the meaning? Any predecessor node on the path from root to that node. So previously we find out a predecessor and successor node. Predecessor means previous, successor means immediate next. But in this ancestor, any predecessor node on the path from the root to that node. Let's look into it. What is the ancestor of E? Predecessor is B and A. From the root, we have to find out what are the predecessor nodes available. So for ancestor of E, A and B will be the predecessors, because here we didn't mention immediate predecessor. Any predecessors from the root to that node. In the path, how many predecessor node will be there? All should be calculated here. An ancestor of C. Let's look into the ancestor of C. In the ancestor of C, so from the root to the particular node, what are the predecessor node? Only one node. That is nothing but the A. The next one, ancestor of M. I am going to the last level. So M. So here if you are looking into the particular one, M is having ACF. From the root node, if I want to reach M, what is the ancestor of that one? ACF. This is what the difference between ancestor and if finding out the parent. Okay, so that is immediate predecessor. This is any predecessor from the root to that node. Next one, a descendant. Descendant is nothing but any successor node on the path from that node to leaf node. Please mention this one. This is leaf node, that is from root to that node. This is very, very important in that. So let's see the example. Descendant of D. I want to find out what is the descendant of D. Here they are giving H and I. That is very important. Any successor. Successor means next. On the path from that node to the leaf node. For D, what is the leaf node? This is the final node. If I am asking for B, this is the final node, right? So for D, this is the final one. So we are reaching the leaf node. So here descendant of D is H and I. Let's look for the A. So here, what is the descendant for A? So I am just mentioning here B, C, D, E, F, G, H, 2, O. Because here I am clearly mentioning any successor node on the path from the node to the leaf node. So clearly it is showing that from A, B, C, D, E, F, G, H, I, J, K, L, M and O. That's all. This all are descendant of A. One more example we'll see. What is the descendant of a G? This is the G. So as I already mentioned, any successor node and next node from the path, that is from the node to the particular node. That is nothing but G, N, O. Okay. For the G descendant, N, O is the descendant. The next terminologies. This is the subtree. So subtree is one of the terminology under the tree in data structure. The same tree I am going to show you how to find out the subtree and how many subtrees will be there. What are the subtrees of A? So the subtrees of A is, this will be the separate tree, one tree, subtree 1. This will be the separate tree, subtree 2. Let's see another one. I am asking what is the subtree of C. The subtree of C is nothing but FLM is one subtree, GNO is one subtree. So this is how you have to find out the subtree. The next terminology is a sibling. So you all know sibling is nothing but what? For the one parent, how many children? This children comes under a single parent. Is nothing but the sibling. The same instruction will be followed to the particular tree in data structure. I am just asking, who are all the sibling of B? The sibling of B is C because they both are comes under a single parent, A parent. Okay, the next one. What are the sibling of he? The sibling of he is nothing but the JK because J and K are the same node. So next one, cousins of he. What is the cousins of he? The friends are the same age people who are coming from the different parents. For example, the cousins of E. If you are taking, I am taking cousins of E, I cannot able to tell D because D and E both are siblings. So I can tell for E the cousins are F and G. So this is how you have to find out what are the siblings and what are the cousins. And the next one, a degree, very important one. So how to find out the degree? Someone is asking, what is the degree of B? What is the degree of K? What is the degree of G? Separate note they are asking. So what you have to do? So degree is nothing but the number of children that particular node is having. So here the number of children of that node. So for example, what is the degree of B? 2. What is the degree of H? H is not having any children, so that is null. So from this what you understood, except the leaf node, every node having 2 children. So the degree of the total tree, how to find out? Here I am asking you particular node degree. If suppose they are giving tree and asking what is the degree of tree, what you will say, what will be the maximum children you have to mention. By seeing this transparently, it is showing that every particular node have 2 children. So 2 will be the degree of the particular tree. Next one, level of node. Level of, how to find out the level of node. So while looking into this particular one, generally I have started with level 0, level 1, level 2, level 3. Manually I have given it, but you have to find out the level in the proper manner. Distance from the root to that given node starts from 0. In every step, hierarchy level will be incremented by 1. I am going to ask you, what is the level of D? Without seeing this, how can you find out? From the root, you have to count the node. So here A is 0, one node, and B is 1, that is another node, and the D is 2. So totally, if I start from 1, it is 3, but here I have mentioned starts from 0. So the degree of level of D is nothing but the 2. The next one, what is the level of B? Level of B is here. As I already said, distance from root to that given node, you starts from 0, you have to find out, count the node, so that easily you can determine this is level 1. And the next one, a level of A. The level of A is a root node. We cannot able to find out to the next node because that is a root node. So root node, it starts from 0. So it's clearly visible that A is from a level 0. The last one, height of the node. So here the height of the node, how to find out the height of the given tree or given node. So the number of edges in the longest path from the leaf node to that node. For example, you take height of M. Here I am just telling height of M. What is the height of M? 0. How can I give the 0? Because a number of edges in the longest path from the leaf node to that node. So M is already a leaf node, it doesn't contain any leaf node. So we cannot tell that particular M having some height. So that is a 0. If I am taking height of A, so for example I am taking A, again you just look into the definition, a number of edges in the longest path from the leaf node. For A, who are all the leaf node? These are all the leaf node. From the leaf node to that node, then you can count it, 1, 2 and 3. You have to calculate the path 1, 2 and 3. So here the height of A is nothing but the 3. Another example, height of C. So height of C is what? Here. So from the leaf node to that node, clearly visible 1 and 2. This is how we have to find out the height of the node. So very important in your real-time application. You should know the difference between a level of the node, degree of the node, height of the node. So here I have mentioned one more thing. Level of tree equal to height of tree. So if I am checking what is the height of the tree and what is the level of the tree, as you all know, the overall level of the tree will be a 3 because I have mentioned in the previous one a 0, 1, 2, 3. Okay, I am just checking. So 3 levels will be the same for the height. The overall height of the tree also be 3. So the level of the tree and the height of the tree both are equal. And the next one, a depth of the node. So the depth of the node, how to find out the depth of the node? Length of path from root to that node. Very important, length of path from root to that node. So here depth of F, just look into the F. So F is nothing but the depth of F is 2. How you are calculating? A length of path from root to that node. That is the opposite. From the root, I am going to calculate. Previously, I have calculated from the leaf to that particular node. Here, I am calculating from the root to that particular node. 1 and 2. Let's see the last one, depth of C. C is here. From the root to that particular node, 1. You have to know the difference between the depth of the node and the previous one. And the level of the node and the depth of the node will be same. So, the level of the node, for example, if I am finding out what is the level of the node of particular B, it is level 1. How we are calculating? Calculating from the root, start from 0 and incremented the value by 1. The depth of the node of B. Just I am checking depth of the B. Starting from root, how many parts will be there? 1 parts will be there. If you checking, cross-checking with every node in the level, every node in the depth, both the value are same. The last one, n node means n minus 1 edges. Suppose they are giving the tree and they are asking how many edges will be existing. First you count the node. Here I am just counting the node. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 nodes will be there. How can I find out the edges? N minus 1. N minus 1 means nothing but 15 minus 1, 14 edges will be there. You can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 15 nodes means 14 edges. N minus 1 edges. This is how you have to calculate it. And the next one. So we have concluded with the terminologies of tree. Okay, this is the logical representation of that one. How to implement that in the memory? That is what the representation of the tree. So here it is a tree in each node having at most 2 children. That is 0, 1 or 2 children. Then only we can consider that particular tree as a binary tree. So just look into this one. So how to store this tree? So this particular root having 2 children. One is from right side, another one is from left side. How can you store that particular one? This is how you have to create a node. This node is nothing but the A node. In the left hand side, I am storing B. In the right hand side, I am storing C. This is what the representation of the particular one. So next one, another example. This also considered to be a binary tree. So what is happening? There is a root node and also there is a child node will be there. One child node will be there. How to represent? A will be the intermediate. And the left side we have that is a B node, and the right side we don't have any node, so we can conclude with a null. So next one, this is what I have mentioned. Node A, here we have B node, here we have a null value. And the last example, this A is containing B child, B is containing D child. How to represent it? There is a node A will be there. In the left side we don't have anything, so I am just keeping it null. And here we have B node. For the B I have one more particular children called D, and this side we don't have anything, so you just make it empty or you can make a null. This is how you have to represent it. How to represent the same thing in the program is nothing but we have to use the struct. Struct is nothing but the collection of multiple data types under a single name. So that is what the struct node. Here this node is nothing but A. So int data is nothing but whatever data you are giving inside it, either one or any character. So whatever you are going to see here, integer I have mentioned means it's a number, and struct node for the left and struct node for the right. The same representation I have mentioned it in the coding way. This particular representation I have mentioned it in the coding way. This is the very important representation. The final, I am going to conclude this with the application. Using the tree, what are the things can be done in the real life? What are the things we are seeing it? So this is what. So you can know everybody are using the laptops and computers. You have many personal documents or personal photos, whatever you have gathered, that should be following the tree data structure. How? There is a directory will be there, there is a folder will be there, there is a file will be there, inside there is a documents will be there. This is how the tree will be framed. Another example, real-time application of tree is nothing but the routing protocol, a binary search tree, quick search and the heap tree. These are all the concept under the data structure, so that you can able to use that particular tree concept in the particular theme. So this is what today's lecture. We learnt about what is tree. Before we have learnt about what is data structure and come into the tree and what are the terminologies of tree, and finally we conclude with how to store that particular tree in the memory. Also what are the application in the particular tree. This is what the today's lecture. Thank you for watching this video.